Hey, what's up? What's up? How are you doing today? Well, we're gonna put Thursday and Friday's lesson, and we're gonna kind of like mash them together. So, on Thursday, we're gonna do the explore that's on page number 111. So, if you were not here, don't worry. I will have data for you to look at. Don't trip out about that. However, I do want to say, if you were not here on that day, don't trip out. I'll give you the data, and then you can move on from there. So, let me talk about this Japan trip just for a second. I do have flyers for this, and then, so I will have them if you guys need them. There is this barcode that's down there, so you could scan it directly from the screen if you are interested. This, meeting is at 6 p.m. on the 4th. You kind of see that down there. And it says you must register for the meeting. So make sure that you understand that. Also, if you pause and take a look at the screen, this gives you some more information. It doesn't give dollar amounts. I'm presuming they're going to talk about that at the meeting. So I just wanted to put that out there for the people. Okay, cool. Let's keep it pushing. If you can be anything, be kind, be respectful, put some respect on your last name. Remember, what you do reflects on your family. Also, make sure to be respectful of me. I'll be respectful of you. And also, when you're at the school, be respectful of each other. Be respectful of the school at large, okay? So yeah. Let's say that. Let's go ahead and again, for this day, we're gonna actually be doing the lab. I'm not gonna really show too much of that. However, let's keep it pushing on to this next part. Again, if you are not here for the lab, just know that we read through the lab, and basically we're gonna be building some ramps, timing the ball, going down the ramp, and seeing if the mass of that has any effect with how fast it's able to go down the ramp. Also, we're gonna, and again right here, this is where we're finding the mass of the ramp. These are kind of the things that we talked about inside of the lab. And again, if you were not here for that, that is okay. I will supply you with data. So hold on. All right, here we are on Friday. Okay, here we are on Friday. And again, we're just kind of pushing through to see that part. I don't want this video to be too long, but here is the data that you can use. So, before I get to the data, we went through the questions, and so we kind of read through this whole thing. So, of course, you want to pause, take time to read through the whole thing. That way you can get an idea for what it is we're doing. I do also want you to circle 15 and 16, okay? 15 and 16, because you need to answer both of those. And then over here where there's questions and a hypothesis. So the question could be something simple about this, like, what is the relationship between mass and kinetic energy? So let's just make a hypothesis. If one object has greater mass than another, then it will have more kinetic energy. Okay, cool. That's a good hypothesis. Now we're going to test that out to see if that is true. Now for the people who do not have data, boom, use this data right here. Again, pause the screen, get this all written down in your journal. I think this is page 113. And then the rest of this video is going to explain and walk through how you go throughout the entire math of getting these things. So you have all this data. If you know how to calculate speed already, calculate the average time and kinetic energy, I'm like, move ahead. If not, I'm going to walk through that in this video. What's up? What's up? What's up? It is Thursday, but it is February 1st. Goodbye to January. We on to February. It is Black History Month. We'll talk about that tomorrow. It's time to do work son though right now, so make sure you go over there and get all the agenda down. We moving forward, okay? I'm moving forward. Oh, no, I went backwards. Okay, so what we're going to do in class, and I'm not going to take the 5 minutes on this video. You need to pause the screen and then take your 5 minutes. Just as a reminder, Explore number 1, Speed in Motion, that was due, okay? I'm going to repeat, that was due on Tuesday. If you look right here, Tuesday the 30th, right? And that is both parts. So that is the written part, and then that also is the digital part. The last two lesson videos on Monday and Tuesday, whoops, swallow some spit, that's terrible, were about those two things, and they're labeled in there, so make sure you can go watch those video lessons if you need it. Linking literacy, we reviewed that yesterday. That was also due yesterday. If you look right here, that was due on Wednesday, so make sure you go over that. Yesterday's video was about linking literacy. By the way, I'm sorry that video was not up yesterday. It was loaded, but I accidentally did not click to put it in the playlist. I apologize sincerely. All right, Cool. So we are moving forward. Okay. So make sure that you take 5 minutes. Make sure all those things are turned in. You also should check, do I have my math packet done? Do I got my iReadies done? Do I got everything so that I can finish tomorrow? Like, what do I need to do today so that I can be done for tomorrow? That's what you should be looking at. Okay. Go through all your emails. Make sure all that's organized. Again, take 5 minutes to get yourself together, and then we're going to move forward. Okay. In the class, that's what we did. I'm not taking the time on this video. You need to pause and take your 5 minutes. Okay. Thank you very much. All right, on to the next. Before we do that, did you take your 5 minutes? I need to know. Did you take the 5 minutes? If you didn't, stop. Take your 5 minutes. Make sure those 2 assignments are turned in, and then obviously go back and check all your other classes. Make sure you're good to go. Okay, now we're moving forward. All right, people. Okay. So again, this is the one assignment. Bam. This is the other assignment. These are the 2 that we're due for this week. All right. Let's move it along. Blah, blah. All right, so now we're here. Mostly everyone went and got data yesterday. Some people might still need to get some more data today. Totally fine if you do. I think wherever my phone is, I think I took a picture of someone's data, and then we are going to use that data in order to calculate today, because I'm going to walk through all of the calculations, okay? I think I need to get a meter stick because that might also be helpful for you as well. So let's do that. So we're going to move here, and we're going to go to this. Oh, we got to do this first part first. So the effective mass. So let's just read this, and this is on page number 111. So we're going to do this first. Then we'll go to the other parts and walk through the calculations of the data and how to calculate the data, okay? All right. Cool. So kinetic energy is the energy of motion. Again, this is on page 111, so you can follow along, and is dependent on the velocity of the object and its mass. By understanding the relationship between energy and the objects of different masses, you can better understand the way objects move. Now, for the question, right, it should have something to do with kinetic energy and mass, so something between these 2. So what a good one is, what is the relationship between mass and kinetic energy? You can write that one in there. Some people wrote, what is the effect of mass on kinetic energy? Some people wrote that in there. So totally cool either way that you want to do it. And then a hypothesis, someone told me, they said, if mass increases or goes up, then what do you think is going to happen to kinetic energy? Is kinetic energy going to go up as well? If mass decreases, do you think kinetic energy will go, then will kinetic energy go down? So again, it's this if-then relationship when you're talking about hypothesis. So if this situation happens, what do I think is going to be the outcome of that situation? So this is a good hypothesis. If one object has greater mass than another object, then it will have more kinetic energy. So some people wrote that. Some people wrote if mass goes down, then kinetic energy will go down. So again, however you want to frame that up, but here are some good examples of a good question and then a good hypothesis, okay, as well. Cool. Now, one other thing you need to do while you're getting that written in there is you need to circle 15. Then you need to also circle 16. There are some questions in there. There are some questions in there that you need to answer, okay? So make sure you do those things. So again, you need to pause on 15. Get that? It says right there, pause. And then on 16, you need to also do that. We will come back to some of these directions because some of these directions are telling you how to calculate things in your data table. But let's just go ahead and take a look. Let's move forward into that, okay? All right, cool. So here we are with the data table. Mr. Farr is going to go ahead and, oh, this is from yesterday. Let me go ahead and save that. I'm going to save all of that and then be like, yo, that was Explore. Oh, that was Explore 1. Boom. And then we'll just put it as a number 2. Yeah, I know. This is not for today. Relax. Save. Boom. And then we need a new one. We need a snip now, right? And then we're going to go ahead and grab this data table. Okay. As a matter of fact, no, we need to grab more. So let's say new. We need an whoops. We need to grab new. So snip now, and then we're going to grab the procedures as well. I want to grab the procedures and the data table. Okay. Cool. So we're going to grab both. All right. Oh, I grabbed myself in there. That's trashy. I'm going to pause and grab it. Okay. Got it now. Sometimes this thing doesn't work the actual way that I think it's going to work. Okay, cool. Oops. So let's go back. I think we can move down here, right? saw. So we can move over. All right, so we're going to go ahead and put the times in that people got. So again, people rolled the ball down, right, down the ramp, and they got their times on what it was. So I actually took a picture of some people's stuff, so I actually have their times. So this right here is going to be 0.92 seconds. That's what theirs was. I don't like how thick this is, so we're gonna lower that down. And then their next time was 0.83 seconds, and their third time was, what they got, 0.76 seconds. All right, cool. So remember, to find the average, we just add these up. So I'm just gonna put them right up here. 0.92 plus 0.83 plus 0.76. Okay, I'll make sure you get that point in there, and then we're gonna divide all these jokers by 3. Okay, and then we'll see what we get. All right, so let's go ahead and see if I can find my little handy dandy Desmos calculator. See if I can find, where is it at. So I'm gonna go over here. I saved it, so I can just pull it up right here. So then I'm like, okay, let's see what we got. 0. Oh man. So 0.92. So 0.9. Ooh, go back. 0.92 plus 0.83 plus 0.76, right? So I got that. That gives me my 2.51. Then I'm just going to take that 2.51 and divide it by 3, okay? And then I come up with 0.83. So I'm just going to go ahead and put that my average time, because I'm going to round these jokers to 1 decimal place, is 0.8, okay? So again, 0. Okay, so I think the video got a little choppy or something. I don't know what happened. So 0.8, so I put my average time is 0.8. I also just added into this data table that what they measured for their distance of their ramp was 45 centimeters. Then they measured that the mass, right, of the ball was 45 grams. That's what they got, right? So I just put that data that they got in there. Now remember, this is centimeters. We need meters. This is grams. We need kilograms, okay? So we're going to have to do some more converting. Now, let me just scroll on down to this thing, okay? We're going to talk about both of these, how to convert both of these. Let me pause because I think it'll be easier to see it if you see the meter stick. Here is a meter stick. Now, in the meter stick, just so you guys know, if you're looking, it keeps going up, up. These are centimeters, right? 70 centimeters, 80, 90, and where it ends is 100 centimeters. Just know that cent is 100. So 100 cents in a dollar, 100 years in a century, okay? So there's 100 centimeters in here. So what they said that they got, right? I just want to double check to make sure I got it. They got 45 centimeters, okay? So that's what they say that they got. All right, cool. So that just means over here where it says 45, that's like, oh, sorry, the camera's right here. That's where they're at, 45 centimeters right there. So that would be 0.45 meters. If you look, it's about 45%, right? 45% of the meter, but it's 0.45 meters, okay? Now I'm going to show you mathematically how we get that. I'm going to show you guys right down here. So what you would need to do, okay, is this. So if we have 45 centimeters, right? So 45 centimeters, I'm going to put that over 1. The conversion factor, right, is that for every 1 meter, there is 100 centimeters. Cool? So then 45, so then I'm going to go ahead, cancel my centimeters. 45 times 1 is 45 over, right? So 45 times 1, that gives me that meter. And then 1 times 100 is over 100, and then we say it's equal to, and we'll do the math so that you can see it, okay? So that you guys can see it. Okay, cool, right here. And then we'll just say, all right, 45 divided by 100 is equal to 0.45. All right, cool. Now, let's go ahead and make that back down, and then that would actually be 0.45 meters, okay? So that is really what it's equal to. So in essence, you just divide by 100, okay? And that will get you to your meters, okay? So 0.45 meters. Okay, now, ooh, what the world? I don't know what it did right there. All right, now for grams, they kind of tell you something very similar, and I'm gonna show you the conversion factor right down here. So they said 45 grams. So 45 grams, and we're gonna put that over 1 times. Now for every 1, right, kilogram, because that's what we're converting to now, there is 1,000 grams. Okay, so that word kilo, so cent is this. Cent is 100, and then kilo, guess what, is 1,000. Okay, so then you're going to go ahead and cancel your grams, okay, and grams, cancel that. So 45 times 1 is 45, and what it is, we got to keep that unit, kilograms, over, so 1 times 1,000, that is 1,000, right? And then you're going to go ahead and do that. And then we'll go ahead and show it to you again. 45 divided by, this time we're going to say enter. So we're going to go 45 divided by 1,000, and you get 0.045 over there. Okay, cool. So we'll press enter, make that small again, and then this time it's going to end up being 0. Oh, sorry if that came out looking like an 8. 0.045. And we got kilograms. Okay, so in essence, you're dividing this by 1,000, and then you'll be able to get it. Okay, cool. So 0.045 kilograms. All right, cool. So now we have everything to the way we need it to be able to calculate everything. So remember this, speed. So now we're down to speed. So speed is equal to distance, okay, divided by time, okay? So our distance in this case is 0.45 meters. So I'm going to put that right in here, 0.45 meters divided by, what is our time? 0.8, so 0.8 seconds, okay? And then now, hey, back to the calculator. Let's do some math. So then 0.45, right? Because that's our distance, divided by 0.8. So then our speed, if we look at this, it's 0.5625, and we've been rounding to 1 decimal place. So that's going to end up getting us 0.6 meters per second, okay? So I'm gonna make that small again right there. And then I'm gonna be like, yo. I'll put it here, 0.5625, right? And that's meters per second. And then we're just gonna round. This is the number we're gonna round, and we're gonna end up right with 0.6 meters per second because we rounded this number. Okay, so I'm just gonna put this around there and be like, that is the number we rounded, but this is the number we end up with, 0.6 meters per second. Okay, you don't have to put this in there. I'm just putting it in there so you can see that that's the number we rounded, and that's how we get it, because we put it right here and we said 5 or more. So it's 5 or more, so we got to up this score. So the 5 went to a 6. Okay, I just want you guys to be able to see that. Now for kinetic energy, remember kinetic energy is equal to, right, kinetic energy is equal to 0.5 times the mass times velocity squared. Now, let's just go ahead and get that in there. This just drops down to be 0.5 times our mass, and our mass is right here. So 0.045 kilograms times, right, times our velocity squared, which is going to be our speed, okay, times 0.6. So I'm going to put that in parentheses because I just like the way that that looks better. 0.6 meters per second, and that is going to be squared. That is what we're going to enter into our calculator. So let's see if I can memorize all of that so we can put it in our calculator, because I keep having to switch screens. All right, so then we're going to press enter to go to the next part. So then we're going to go 0.5 times our our mass, which is 0.045 times our velocity, which is 0.6 squared. That is exactly what we wrote down. Let's just double check, discount double check, and be like, oh yeah, that's it, that's the one. So then our answer is 0.0081 or 0.008. That's our answer, right? So we're going to go ahead and just get that right in there to say that it is, and I'm going to put a square around it so that way we can make sure to know that that's our answer. So it's 0.008 joules. That is our answer for kinetic energy. Now that's how we walk through this entire problem. So it is quite, just to get down to the kinetic energy, it's quite a few steps, okay? So you just need to repeat those exact same steps for B and for C, and then you'll be able to calculate them all. I will tell you this, write down everything. The people who keep skipping steps, those are the people who are not writing things down. Those are the people who are finding it the hardest, because you need practice and you need to be able to be like, okay, yeah, that's how I calculate. Oh, that's how I converted. I see, I got the conversion factor right here. Okay, that's how I convert from centimeters to meters. Okay, this is how I convert from grams to kilograms. Okay, cool. Oh, that's how I calculate speed. Oh, we round it right there. Yeah, okay, I got that. So you need to be able to see all those things. That's why you need to write all of the information down. That way you have practice problems and it solidifies it inside of your mind. All right, y'all, that is it for the day. If you can get all your math done, we'll deal with the graphs tomorrow. Peace!